In the vast universe, light travels as an electromagnetic wave vibrating in countless planes, wild and disordered. Polarization. Polarization is a phenomenon that occurs in transverse waves, such as light waves, where the vibrations are restricted to a single plane. Normally, the vibrations of a transverse wave occur in multiple directions, but after polarization, they are confined to just one direction. This can be achieved using a special material called a Polaroid, which acts as a filter, allowing only waves vibrating in a particular plane to pass through. Polarization is commonly used in sunglasses, photography, and optical devices to reduce glare and enhance clarity. To observe the phenomenon of polarization of light using two Polaroid sheets. Materials required: 2 Polaroid sheets, light source, cardboard, white paper, scissors, glue, compass, ruler, pencil, protractor, paper cutter. Procedure. Paste the white paper over the cardboard using glue. Measure 10 cm using a ruler, and at the center of the paper, draw a circle with a radius of 10 cm using a compass. Cut out the circle carefully with scissors. Mark the angular divisions in the circle using the protractor. Cut a small center hole. Paste very little glue at the 4 corners of the Polaroid and place it at the center of the circle. In a similar way, another identical scale is made for Polaroid 2, which is called the analyzer. Hold Polaroid P1 in front of your eye and observe the light. Place the analyzer Polaroid P2 over P1 and observe the light intensity. Now, keeping the P1 constant at one point, rotate P2 until maximum light intensity is observed. The difference between the readings of P1 and P2 is marked as A. At the position of maximum intensity, A is defined as 0 degree. Gently rotate P2 until the maximum intensity of light changes to a minimum. Now record the reading of the analyzer P2 at minimum intensity. At this point, the angle denoted as B is 90 degree. Observation and result. When scales of both P1 and P2 are at 0 degrees, we observe maximum intensity of light. When P2 is rotated over P1, intensity of light reduces to a minimum at 90 degrees as they are perpendicular to each other. Again, light intensity becomes maximum at 180 degrees and minimum at 270 degrees. Bright again at 360 degrees. Inference. It is observed that when light passes through a polarizer, its vibrations are restricted to a single plane. When an analyzer is rotated, the intensity of transmitted light varies, becoming maximum and minimum at different angles. This confirms that light is a transverse wave and can be polarized, proving that its vibrations are perpendicular to the direction of propagation. Applications on real life. Polarization isn't just a lab trick, It's vital in polarized sunglasses, photography, LCD screens, and scientific research. Conclusion. Polarization reveals the hidden structure of light. By mastering it, we unlock new frontiers in optics, communication, and imaging. Your journey into wave physics has just begun. FAQ. Why does light vanish at 90-degree rotation? Because the transmitted component becomes zero and the light aligned at 90 degrees is completely absorbed. Can sunlight be used directly? Yes, but indirect sunlight or reflected light works better to avoid eye strain. Does intensity gradually change with rotation? Yes, intensity follows Malice's law. I is equal to I O cos squared theta.